All right, in this video, we are going to be converting from logarithmic equations to exponential equations. So just opposite of what that last video was. So what we're going to do is use this base. That'll be the base of your exponent. This number that's on the right side of the equal sign will be your exponent. Then that is going to be equal to what is in the left side of the equation, 27. 3 cubed equals 27 is the equation that you get when you convert from log to exponential. On this next example, we have log of 0.0001 equals -4. Okay, remember the base of your logarithm is the base of your exponent. You can't have an exponent floating in the air without something that's being raised to that exponent. I don't see the base like I did. I saw the 3 on the last one. If you don't see the base, remember it is automatically base 10. So that will be the base. That will be raised to the number on the right side of the equal sign. So -4. And then that will be equal to the number on the left side of the equal sign. So 0.0001. All right, on this next example, we have ln of 2 equals 0.6931. So what we have here is I don't see the base again. So if I'm going to write an exponent, I have to have a base. If you see ln here instead of log, that's your natural log, which is log base e. So that is what that would look like. Ln is log base e of 2 equals 0.6931. So now I can see that the base of my exponent will be e. I'll raise it to the power that's on the right, so 0.6931. And then that is going to be equal to the number on the left side of the equal sign, which is 2. I'm going to use the last part of this video to find common logs in the calculator. So we are going to find the logarithm and then we are going to round it to 4 decimal places. So I want to find the log of 97. So I am just going to hit the log button on my calculator and then type in the 97. Enter. If I round this to 4 decimal places, I go 4 numbers after the decimal. So I have 1.9867. But after that first 7 is another 7. So since it's 5 or greater, I do need to round that up to 1.9868. What happens if you find the log of -39 and you put that in your calculator? So I hit the log key, then -39 and close. Here, when I put that in, it tells me it's not a real answer. So this answer does not exist. Because remember, when you are taking or finding a logarithm, you are finding what power the base of the log needs to be raised to in order to equal what is in this position. Okay? Remember, if I don't see a log, it's automatic. If I don't see the base of the log, it's automatically base 10. I'm not going to be able to raise 10 to a power and turn it into a negative number. That's why that does not exist. Look at the answer before. That log of 97, do you see how it's very close to 2? Because if I don't see the base, it's automatically 10. 10 to 1.9868 is going to equal 97. Remember, 10 to the first is 10. And what is 10 to the second? It's 100. That's why 10 to the, it's almost squared, right? Because 97 is almost 100. So that's what you are finding. That's why if this number inside this parenthesis here is negative, it's just not going to exist. All right, if I find a couple of more, I'm finding natural logs. So ln of 13. So again, in your calculator, you'll just hit the ln button, which is the one right below the log button. Ln of 13, enter. And round that to 4 decimal places. So I have 2.5649. After the 9 is a 4, so I don't need to round up. So here I have 2.5649. And once again, if I have ln of negative 1.18, and I put that in my calculator, just like when I took the log of the negative number, when I do the natural log of negative 1.18, it again is going to give me an error message. So this one again does not exist.